How do satellites perform a deorbit burn? Imagine a satellite reaching the end of its mission and needing to leave its orbit safely. How does it do that without causing chaos in space? That's where a deorbit burn comes into play. This is a controlled engine firing that helps the satellite lower its orbit and eventually re-enter Earth's atmosphere. The main goal is to make sure the satellite burns up safely and doesn't turn into space debris. First, mission controllers plan the deorbit carefully. They calculate the exact time, how long the engine should fire, and how much thrust to use. They often aim the burn so the satellite's trajectory ends over remote ocean areas. This way, if anything survives reentry, it won't harm people or property. The timing and duration depend on the satellite's size, weight, and orbit. When it's time to perform the burn, the satellite's onboard propulsion system ignites in a direction opposite to its movement. This is called a retrograde burn. It's like pressing the brakes on a car butt in space. The engine firing reduces the satellite's speed, which causes its orbit to lower. As the satellite slows down, its closest point to Earth, called the perigee, drops into denser parts of the atmosphere. Once the perigee dips into thicker air, atmospheric drag increases sharply. This drag causes the satellite to lose altitude quickly. As it descends, friction heats it up, and most satellites burn up around 75 kilometers above the Earth. The process is quick and controlled, ensuring the satellite doesn't break apart prematurely or cause debris. Ground stations keep a close eye on the satellite during this process. They track its descent to confirm it re-enters safely and complies with safety rules. Different satellites use different propulsion methods for deorbiting. Some have chemical thrusters, which provide a quick burst of power. Others use electric propulsion, which is more efficient but takes longer. Small satellites or CubeSats without onboard engines might use passive methods like drag sails or tethers. These devices increase atmospheric drag, speeding up the decay process without firing engines. Deorbit burns are especially important for satellites in low Earth orbit. Regulations often requiring satellites to re-enter within 25 years after their mission ends. This helps reduce space debris, which is a growing concern. For satellites in higher orbits like geostationary orbit, moving them to a graveyard orbit is often the better option because re-entry would requiring a lot of fuel. In simple terms, a deorbit burn is a carefully planned engine firing that slows down a satellite, making it fall back into Earth's atmosphere. It's a vital part of space operations, helping keep space safe and clean.